Watch until the very end, because what happens when a planet almost falls into a black hole is far stranger than just being destroyed. It might survive in a way that completely breaks your understanding of reality. Picture this. A planet drifting through space gets too close to a black hole. Not close enough to fall in instantly, but close enough that escape is no longer simple. In the first 10 seconds of this scenario, everything already starts going wrong. Gravity spikes, time bends, and the sky itself begins to distort. From the surface of that planet, the universe would no longer look normal. Stars would stretch into arcs, light would twist into rings, and something even more disturbing would begin to happen. You would start seeing the same stars multiple times in different places in the sky. That's because the black hole's gravity bends light so intensely that it wraps around it, creating warped duplicates of everything in the background. The sky wouldn't just be strange, it would feel broken, like reality is folding in on itself. Now, here's the part that makes this scenario so extreme. The planet doesn't fall in immediately. It gets trapped in a deadly dance, orbiting dangerously close to the edge, just outside the point of no return. This region is where physics starts behaving in ways that feel almost impossible. From far away, an outside observer watching this planet would see something very different from what's actually happening. To them, the planet appears to slow down as it approaches the black hole, slower and slower, as if time itself is freezing. Eventually, it would seem like the planet is stuck, hovering at the edge forever. But on the planet itself, time feels completely normal. Seconds pass, minutes pass. Life, if it exists there, continues to experience time as usual. This is one of the most mind-bending effects of extreme gravity. Time is not the same for everyone. Near a black hole, time stretches. It slows down compared to the rest of the universe. If you could survive on that planet for just a few hours, when you escaped and returned to normal space, you might find that years or even centuries had passed everywhere else. Now imagine the consequences of that. Civilizations on that planet could watch the future of the universe unfold in what feels like a short time. Stars aging faster, galaxies evolving, everything outside moving at a different pace. It would be like living in a time machine without ever leaving your world. But survival near a black hole is not just about time. The real danger is tidal forces. Gravity near a black hole is not uniform. The side of the planet closer to the black hole feels a stronger pull than the far side. This difference stretches the planet, slowly at first, then more violently. If the planet gets too close, it won't just break apart. It will be stretched into a long, thin stream of matter, pulled apart atom by atom. Oceans would rise into towering waves that never fall. Mountains would collapse and stretch. The entire surface would distort beyond recognition. But here's where things take a surprising turn. Not all black holes are the same. Supermassive black holes, the ones at the centers of galaxies, behave differently. Their immense size actually spreads out the tidal forces over a larger area. That means a planet could get much closer before being torn apart. In some extreme cases, a planet could orbit very close to a supermassive black hole and remain intact for a long time. That means there could be worlds out there, orbiting just outside the event horizon, surviving in one of the most extreme environments imaginable. Now think about what the sky would look like from that world. The black hole would dominate everything. A dark sphere surrounded by a glowing ring of light from superheated gas spiraling inward. That ring would shine brighter than anything else in the sky. It wouldn't rise and set like a normal star. It would just hang there, massive and unchanging. Around it, you would see the distorted universe warped into arcs and loops by gravity. Light from behind the black hole would bend around it, creating a glowing halo. You might even see the back of your own planet's orbit, reflected in impossible ways. It would feel like living inside a cosmic illusion. Now let's go deeper into what happens to the planet's orbit. When something orbits a black hole this closely, it doesn't follow a simple circular path. The orbit becomes unstable. Tiny disturbances can have massive effects. The planet could spiral inward slowly over time, inching closer and closer to the event horizon. But it might not fall in smoothly. There's a possibility that it gets caught in a chaotic orbit, swinging closer, then farther, in unpredictable patterns. Each pass near the black hole would expose it to intense radiation and gravitational stress. This is where things get even more dangerous. Black holes are often surrounded by accretion disks, massive swirling clouds of gas and dust heated to millions of degrees. These disks emit powerful radiation, including X-rays and gamma rays. If the planet passes through or near this disk, its surface could be blasted with energy strong enough to strip away its atmosphere. Imagine standing on that planet as the sky suddenly lights up with intense radiation. The air itself could begin to break apart. The surface could heat up rapidly. Any form of life would face extreme conditions beyond anything we experience on Earth. And yet, the planet still hasn't crossed the event horizon. It's still hovering on the edge between survival and destruction. We're about halfway through, and if your mind is starting to bend a little from all of this, now is the perfect time to like the video, subscribe, and turn on the notification bell so you don't miss the next deep dive into the universe. Now let's explore something even more fascinating. What would happen to signals sent from that planet? If someone on the surface tried to send a message out, it would face a strange problem. As the signal climbs away from the black hole's gravity, it loses energy. Its wavelength stretches, shifting toward the red end of the spectrum. This is called gravitational redshift. To a distant observer, the signal would become weaker and slower. Eventually, it would fade away, becoming almost undetectable. At the same time, any signals coming toward the planet from the outside universe would appear sped up. Light would be blue-shifted, increasing in energy. The planet would receive a compressed, accelerated version of external events. That means if you were watching the universe from that planet, you might see events unfold faster than normal. Stars exploding, galaxies changing, all happening at an accelerated pace. It would be like watching the universe on fast forward. Now here comes one of the strangest possibilities. There is a region around a spinning black hole called the ergosphere. In this region, space itself is dragged around by the black hole's rotation. Nothing can remain stationary. Everything is forced to move along with the spin. If our planet enters this region but stays just outside the event horizon, it would experience extreme frame dragging. Its orbit would be influenced not just by gravity, but by the rotation of space itself. This could lead to bizarre orbital paths where the planet is effectively being pulled along by the spinning fabric of spacetime. And here's the truly mind-bending part. In theory, energy could be extracted from this motion. An advanced civilization on that planet might be able to harness the rotational energy of the black hole. Instead of just surviving, they could use it as a power source. The most dangerous place in the universe could become the most powerful. But survival would still be incredibly fragile. Over time, gravitational interactions, radiation, and orbital instability would likely push the planet closer and closer to the event horizon. And eventually, the inevitable would happen. The planet would cross the boundary. From the outside, it would appear to freeze forever at the edge, fading into darkness. But from the planet's perspective, it would cross in a finite amount of time. And beyond that point, we simply don't know what happens. Physics, as we understand it, breaks down. But before that final moment, there's one last question. Could a planet ever escape once it gets this close? In most cases, no. Once it's deep within the black hole's gravitational grip, escape requires more energy than is possible. But in certain rare scenarios, interactions with other massive objects or gravitational slingshot effects could potentially alter its trajectory. It's incredibly unlikely, but not completely impossible. Which means there could be planets out there that have come dangerously close to black holes and survived. Think about that. Worlds that have experienced extreme time dilation, intense radiation, and warped space. And still exist. Before we reach the end, I want you to drop a comment and tell me this. If you had the choice, would you visit a planet orbiting just outside a black hole, knowing what it would do to time and space around you? And if you've made it this far, don't forget to like the video, subscribe, and hit the notification bell. Because the universe is full of scenarios that challenge everything we think we know. Here's the final takeaway. A planet that almost gets swallowed by a black hole doesn't just face destruction, it enters one of the most extreme environments possible. Time stretches, space bends, light distorts, and reality itself starts to behave in ways that feel almost unreal. It becomes a place where the normal rules no longer apply. And in that narrow boundary between survival and annihilation, we see something incredible. Not just the power of black holes, but the limits of our understanding. Because right at that edge, where a planet is almost lost forever, the universe reveals just how strange it truly is.